Okay guys, so we'll get the formulas written down for these, and then you'll be able to use them on your assignment. So the ellipse, like I said, could be more horizontal, like side to side, or it could be more vertical. But there is a center point in the ellipse. There's an obvious center point. I'll just put C on this one, but yeah, that's the center. See? You have a center point, and the center point, you would label the center point as H and K. That's the center. The center of each of these would be H comma K for both of these. Center point of this one, it would be H and K. Alright, so now the formula. The formula goes x minus h, whatever that center point is. It'll be x minus h squared over a squared. We'll talk about what a squared is in a minute. And y minus k squared over b squared equals 1. If the ellipse is more vertical, the formula is almost the same, it's just a tiny bit different. But if the ellipse is more vertical, the formula goes x minus h squared, and the b squared is there. And then y minus k squared over a squared equals 1. So like the a and the b switched places there. Okay, so what is this A and B? If the A is see, it's in a different spot. The A and the B. I just highlighted the A to show you it switched places. A and B like switched when it's more vertical. Okay, so the A number is like how long it is. Like this ellipse side to side. You would like let's say to get to the side, to get to the edge over here, let's say it was like 3 spaces away. So like A would be 3 maybe, just for an example. The A number is like how far it is from the center to the edge. Like if I had to go 3 spaces that way to get to the edge of that ellipse, or if I had to go 3 spaces this way to get to this side, then A would be 3. You know, just for an example. So the A number is like how long it is, the longest side, like the longest, or up and down. This one's more up and down. See, like this ellipse I drew like longer up and down, it's more vertical. So let's say it was like 4 spaces to get up to the top of that, from the center to the top. Let's say it was like 4 spaces on a graph, and maybe 4 down. Then this number would be 4, and you'd have to do 4 squared and make it like 16. It'd be like 4 squared, just for an example. So the A number is a distance from like the center to the top, or center to the bottom, or center. It's the longest way. You know, it's called the major axis actually. The long, if it's either long horizontal or if it's a long ellipse up and down, the A number is how far it is from the center to the edge. And the B number is the shorter distance. So this is like A. Like how far it is from the center to the edge, that's A. And then the shorter distance, like this ellipse is skinnier this way, so then the distance from the center to the edge of this would be B. And this one's, like I said, just the opposite. Like the distance from the center all the way down to the bottom of it would be A, and the distance from the center to like the edge would be B. Like the shorter distance is B. Okay, so let's do an example so you see how this works, guys. With real numbers and stuff. Really quick. Okay, so let's do an example. Let's say you had a formula and it went x minus 1 squared over 4 plus y plus 2 squared over 9 equals 1. Okay, so here's an example. Got the formulas up here. Let's look at this example. Okay, so if you just look at this formula, could you figure out what the center is of this ellipse? So I wrote a formula, x minus 1 squared over 4, y plus 2 squared over 9. What's the center? Well, the center, if we look up here again, the center is supposed to be the h, k numbers. So see h, k, where they are? So what's the center of this problem? 1, negative 2. Good job. See, it's just the x minus 1, so it's positive 1. This one says plus 2, so it's negative 2. So notice the sign changes. So it's, yeah, positive 1, negative 2. That's the center of the ellipse. Yep. Okay, now, the bottom numbers. See the 4 and the 9 on the bottom? So is this ellipse horizontal or vertical? The bigger number, where's the bigger number at? Here's the bigger number, right? So like A is greater than B. If you look for the bigger number is 9, right? So the bigger number 9 is under the second part, is under the Y. That's why I kind of like highlighted that to show you. The bigger number is always A. So that makes this ellipse a vertical one. Because A squared is 9. See this 9 right here? That's A squared, the bigger number. So what does A equal if A squared is 9? What's A? Yep, 3. Okay, what's B squared? If A squared was this 9, what's B squared? The 4 over there, yep. So what's just B? 2. Okay, now I'm going to graph it. Alright, so let's graph this thing. So you told me the center was 1, negative 2. Okay, there's the center. 1, negative 2. Made a dot. Just graphed it. Okay, so since the bigger number is under the y part, the bigger number is under that second fraction y, that means it's more vertical ellipse, up and down, y. Because y is up and down. So A is 3, we just said. So you know what you have to do to graph this thing? You just go from the center, and you just go up 3 and down 3. You just count like 1, 2, 3. I'll just make a dash. Dashes on. I'm just going to go 1, 2, 3 to there. And then I'll go down 3. 1, 2, 3, like to there. So see, I'm going like up and down 3. The A number is 3. I'm going like from the center, I'm just going up 3 and down 3 to make my graph. And then from the center, if B is 2, you go like left 2 and right 2. You just go left, right 2 to there, go left 2, make a dot over here. And then it's kind of like a football oval shape or egg shape. You try to draw it. Obviously, when you do your assignment on the computer, you just pick out which graph is the right one. But I'm doing it by hand here. So just remember the bigger number. If the 9 would have been under this one, if the 9 and the 4 would have been switched, then it would have been more horizontal. It would have been longer side to side. I would have went 3 this way and 3 this way, and 2 up and down and made it more oval horizontal. But since the bigger number was under the second fraction, it's vertical. Okay, and then there's one more thing they ask you to find on the assignment. They ask you to find the focal points, the foci. When you have these ellipse shapes, the focal points, there's like 2 focal points. Here, I'll just draw a big ellipse. So the center, we've talked about the center, talked about how to know how long it is and how wide it is. Focal points are like points in here. like focal point here, focal point here. So the focal points, to find those, you have to do a little formula. It's almost like the Pythagorean theorem. To find the focal points, it's again like have to figure out how far away it is from that center point. To find these focal points, it's like the Pythagorean theorem almost, but it goes a squared minus b squared equals c squared. To find the focal points, you have to find c. See, because we already know what a squared is and what b squared is, so we should be able to do it. It's like the Pythagorean theorem, except the sign's different. See, Pythagorean theorem is a squared plus b squared equals. But to find the focal points, it's a squared minus b squared. So let's see, a squared was 9 in our problem. B squared was 4. So you just have to do 9 minus 4. Because we already know what a squared and b squared were. 9 minus 4 is 5. But that's c squared, so how do you get rid of the squared? Yeah, take the square root. C equals the square root of 5. And you can just leave it as square root of 5, you guys. Square root of 5 does not come out nice on a calculator, you know. Square root of 5 is 2.236067977. You know, it's like a big, huge decimal. So they just leave it as square root of 5. It is approximately 2.23. It means like the focal points are like about 2 spaces away from the center. Like the focal points would be like here and here, inside, away from the center just a little bit. Because square root of 5 is like 2.2. So the focal points would be like in here. So they ask you sometimes to write the focal points. So the focal points, to write the answer for where the focal points are, you go from the center. You know, the center was 1, negative 2, right? 1, negative 2. That was the center, though. So to get to the focal points, instead of being at negative 2, I'm like adding, I'm going up square root of 5. So you do negative 2 plus square root of 5. Like that. See, it's like the center point, but you're going from that center point, negative 1, negative 2, then you're going up square root of 5 to get to the focal point. And how do you get to the other focal point? You go down square root of 5. So it's like plus or minus. See, negative 2 plus or minus square root of 5. That's the focal points. And they have you write it like that. See, I'm telling you, just leave it as square root of 5. Don't put the decimal. They tell you just leave it in the radical form. Because square root of 5 is 2.2360679. They don't want you to put that big decimal. They want you to just leave it as square root of 5. Because it's more exact. You didn't have to round it off. They like to keep things in radical form. So yeah, finding the foci is a little tricky. Pythagorean theorem, and then you have to add that square root of 5 to the y value, like go up and down to get to those focal points. Okay, let's see, there's one other thing, I guess. Okay, and then, so we went over these formulas. There's one more thing. Sometimes the problem they give you in the assignment is not in that, is kind of like not in this format. This is the standard format for these ellipse equations. And sometimes they give you a problem like says 25x squared plus 4y squared equals 100, let's say. This is an ellipse. Like I'm just telling you, that is an ellipse equation, but it's not in that standard format with these fractions. Like the one we just did had all these fractions. And the standard ellipse problem over here, it always equals 1. See that? It says equals 1. Well, the problem I just gave you says this stuff equals 100. Well, see, so I can tell it's not in the standard form. So let's see if we can get it into standard form. Get this into standard form. It's actually easier than you think. It's not really that hard to do. How do you get it in standard form? Well, like I said, it's supposed to say equals 1. these formulas say equals 1 at the end. So instead of equals 100, I want it to say equals 1. So all you have to do is divide the problem by this equals number. It says equals 100. If you divide 100 by 100, what do you get? What's 100 divided by 100? 1. So if you divide by 100 everything in the problem, you'll get it in standard form. If you just divide by whatever this last number is. So if you run into some of those on your assignment, you just divide by that last number. Okay, so 25 over 100 right here, that's a fraction and you can reduce it. How many times does 25 go into 100? Yeah, 4 times. So it'd be like 1/4. See, then it's just like 1x squared over 4. You don't even have to write the 1, 1/4. And then the second fraction is 4 over 100. Well, 4 goes into 4 once. What's 100 divided by 4? If you have 4 over 100, yeah, it's 25. Good job. And then 100 divided by 100, like we said, is 1. Now it's in standard form. What's the center of this ellipse? Now I got it in standard form. What's the center of it? Can you tell what the center is? So, yeah, it's the second answer you just said. If there's no numbers by the x and the y in the numerator, yeah, it's going to be, the center is 0, 0, because it's like x plus 0, y plus 0 squared. Yep, center is 0, 0, when there's no numbers up there in the top. Center of this one's 0, 0, because there's no x number and there's no number by the y. And then, could you tell, is this a horizontal or a vertical ellipse? Can you guys tell? Yeah, the second number, the 25 is bigger, and 25 is under the y, and y is up and down on a graph, so it's more vertical. Yep, this is a vertical one also. So if I was going to graph it again, I would just go to 0, 0 on my graph. And then how tall is this ellipse going to be then? Like how far up should I go and how far down should I go if it had a 25 right there? Like a squared is 25. Yeah, so a is 5. So I should go up and down 5 from the center. You just go up 5, down 5. 1, 2, 3, 4, 5. Now this is called the major axis. How long it is? That's called the major axis. Like that whole height of how tall it is. That's called the major axis. So how long is the major axis of this problem? How tall is that altogether? How long is it? We went, yeah, it's 10. So, because some problems they tell you the major axis, like say the major axis is 10, so then you should know A is 5. Then you figure out A, well, A is just half of that. Because sometimes there's a problem they give you the major axis. So then they say, well, then write the equation. So then you'll have to know A is 5, and 5 times 5 is 25. See, it's like you have to sometimes work backwards on these. And then the B number is that 4. The B squared is 4. So how much is B? B is 2, yep. So when you graph it, you just go side to side 2 spaces. 2 spaces this way, 2 spaces this way. And that's how wide the oval ellipse is. That's how wide it is then. And then they would graph it. And now side to side, that's called the minor axis. Like how wide it is side to side, that's called the minor axis. So the minor axis, how wide was that ellipse then altogether? That was 4, right? We went 2 each way. So that means like B was 2. So try to remember like the length of the whole major, like the whole major axis was 10. So that means A was 5. You know, like we went 5 up, 5 down. So I'm trying to explain all that stuff because, yeah, sometimes they give you this stuff first and they tell you to write the equation. See, so sometimes you have to go backwards. Like this one, I gave you the equation and we graphed it. What if they gave you the information and you had to write the equation? And you go like back and forth. So hopefully you're kind of catching on to it. That's the type of questions you're going to see. And I can come around and help you if you get stuck on something. But yeah, you have to think, yeah, the long way is called the major axis, and the short, the skinnier side to side, so that's called the minor axis. And again, if it was if your ellipse went this way, then this whole thing would be the major axis. See, it's just like different orientations, you know. If it's longer up and down, then the major axis is up and down. If it's longer this way, then that's the major axis. So like if I told you the major axis was 14, then could you figure out what A is? Yeah, then A would be 7, and then you would have to do A squared would be 49, and you'd put a 49 in the bottom of the fraction. See, you have to like know how to work it out. And let's say the center was at the origin. Do you guys know what origin means? Some people forget what origin is. If I told you the center is at the origin, what does that mean? Yeah, so center, origin, that means 0, 0. And then let's say I told you the minor axis, that would be like this way, up and down. Let's say I told you the minor axis was 6. So then how much is B? If this whole like length of this was 6, how much is B? Yeah, then B is 3. If this whole thing is 6, B is 3, and 3 squared is 9. So then I'd be plugging in like 9 and 49. Then I could write my equation. It'd be like x squared over 49 plus y squared over 9 equals 1. And that'd be the answer. See, so like if I give you the major axis and minor axis and the center, you should be able to write the equation. And see, this one was more longer side to side, so the bigger number went under the x, because x is side to side. X-axis goes this way. So I hope you're catching on to that stuff, you guys. Like I said, you can work on it on the computer. It's lesson 7.1. I can come around and help you. If you get done with that 7.1, which some of you work pretty fast, and you will, you can start the review for final. There's one called review for final on there. Oh, okay. It was on the computer, wasn't it? Yeah. Okay, we can get to that. And then something I forgot to question.
Let's
So the y-intercepts are yeah, so 3 or 0, and then this is 0 yeah, it's tricky, isn't it? All these yeah, when they have numbers in them, then you don't, but all the other ones, yeah, you have to put a plus. Add 1 to your power. Yeah, you add 1 to your power, divide by your power, yep. And then 2x to 3 halves, 5 halves, yep. That's right. And then plus c after it, that's right. I actually have this, I have this, oh yeah, the absolute value is kind of tricky. Chapter 4. I can do it. To show you. That's fine. I'm going to go do this quick. They said no. Oh shoot. Okay, the absolute value. I was going to find that example in the book that did one. It might have been gone when I explained it. It's fine. Oh, here's one. So absolute value, you know, it's like the graphs are like shaped. So you have to know where the B is. Absolute value. Like when it's just absolute value, X, then the center is like right here. So like right now the graph is like this way. So like they have one in the book that has the interval from -4 to 1. Absolute value. So if you think of the graph of the absolute value X, I was very surprised. So it's really just a straight line over here and a straight line over there. So you have to know where the center is. And then you can break this into like two intervals. Like you said, you can read it from -1 to 1. Well, we just want to actually go from -1 to 0, where you have to actually rewrite it as -1 to 0. What if I get in fifth grade and go from 0 to 1? Okay, so you notice it's just a line, but this line is like going downhill, like a negative slope, and this is going uphill, like a positive slope. So you just change this on this side, you have like this one, like those things like negative, that goes down, you change it to negative. And then this line is positive, because it's like positive. So every time you get an absolute value problem, you gotta know where the center is. Split it into two intervals and just change the sign of the first one, like this was. Like, so even if it's like a number like this, it would have said like 7 plus absolute value of x. Then I would have put 7 minus x. And then this one I would have done 7 plus x. So it's still around. Yeah. This one you're going to be 7 plus x. Change the sign or whatever it is. 3 plus x, 3x, and then you do another interval and this one. And where's the center of this? -0, so you create from -1 to 0, and this one's 0 to 4. So it's like doing two separate problems. You can add the answer up. Like you get this answer and then add it together. Wait. Yeah, because it's like you get intervals help find area. So it's like the area of this here plus the area of this here. Because you'll get the answer, like if I did this one, it would be what, x squared over 2 right here. And then you would evaluate it from -1 to 0. And this would be x squared over 2, evaluate it from 1. And I'll get, remember it's like f of 0 minus f of t and f of p minus f of k. So if you go to 0, you get 0. We'll go back to that next year and follow that out. Yeah, and it's minus. Minus maybe 1/2. It's really plus. So you do like half, like the area under there is a half. And then I bet if I do the area on this side, it's half. And then we can add it together, and it's like 1. Yeah. So it's just like piecing it together. It's really no, so each of those things you'll have to break it up like 3x to the third divided by x squared, and then x squared over x squared. You can reduce them. 5 over x. Yes. Yeah, then you'll have to integrate that. Okay, well, you can use those. Okay. And then after, so for the I started out with another. Oh yeah. Yeah, so you put extra force in there, and then it's squared. So when it's a power, and then it's not even another power, you're actually 9 it. Yeah. Okay. And then 5x plus 4. And then the derivative of that is that. Now you just do that. Yeah, so that absolute value one on the front, like you're practicing it now, and then there is one like that on the final. I have one other teacher final to practice. This one's the rough control. You know? Okay, I'll ask you a question. Yeah. So A is always the big one. So, yeah. Okay, now the graph, so let's see, this the y intersection of the y. I think it's fine, because it's square root of 9 is 3. That's the only thing they got. That was done, right? So, yeah, so you do 1 now, so you just put 1 over. But like from the center over to the side is just 1 space. And 1 square is 4 to 1. Yeah. Put it 1 around. Okay. Yeah. Okay, so you basically have the right answer. They're wanting you to simplify your radical now, which is like 9 times 3 is 27. And the 9 to the third square. The square root of 9 is 3 is 5. Like, yeah, 27 is right. It's right. But it's another form. Yeah, it's just like always radical. Yeah. Well, you should still see it pretty well. Oh, hang on. The both side. Oh, okay. So if you have the both sides here and here, they want you to find the center. You just have to like find halfway between them. They gave you like the coordinates for those, so you just have to go to the middle. Like okay. So if you graph it, it just kind of counts to the center. Okay. Halfway between them. Yeah. Okay, sorry. Okay, systems and intermediates. Okay, so I'll go on the computer to the left. Okay.